Well, hello, and welcome to the Mechanical Engineering Department. This is the first video in a series of videos that I prepared for you so that you can evaluate how well you're prepared to begin mechanical engineering classes. So let's get started. Here's the idea. There's a number of things you need to be prepared with as you come into the mechanical engineering department. And we want you to perform well in all your classes. What does that mean? On the short term, it means getting a good grade. I want you to get a good grade in your class. On the longer term, I want you to perform well in classes in order to prepare yourself to become a practicing engineer. And the way to gain and get good performance in your classes, the way to get a good grade, is to be well-versed in mathematics. And so the series of videos that I prepared for you is to enable you to sort of self-evaluate. Nobody else is going to evaluate yourself on your preparation level for these various aspects of mathematics. And this video is going to look at how your preparation level for algebra. So let's go ahead and give some example problems to see how you would do in your head. Okay, here's the expectations we have in the ME department, and that is that you need to be able to easily manipulate mathematical expressions in order to solve one equation and one unknown when a variable like X can be solved for. In other words, looking to use algebra so that you can determine the expression X equals blah, 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 blah. Okay, some mathematical expression. That's the idea. So you're thinking, okay, let's see how I do on that. First example, how would you determine the area, the diameter of circle when you're given the area? So here's the problem. Given A, the area, find the diameter D. Area of a circle is 0.087 square meters. Determine the diameter of the circle in centimeters. Let's start with a sketch. And so there's my very simple sketch of a circle, diameter equals question mark, and the area is 0.087. All right. Think about how you would solve this problem on your own as you go along. I would hope you'd start with a sketch if this were a homework problem. The next, we'll sort of write down, well, what applies? A equals pi over 4d squared. That's the area of a circle. Then you got to do a little mathematical manipulation because you're trying to get to d equals, okay? And so next step, multiply both sides by 4 over pi, okay, to cancel out the pi over 4 on the right-hand side, okay? Then we'll solve for d. We'll take the square root of both sides, flip d over to the left-hand side to say d is the square root of 4a over pi. Pretty straightforward. And you would show those steps as you go along in your solution. And so you solve for d and you look at your units. Okay, d is 0.3328 meters. And in the problem statement, it said express your answer in centimeters. So we simply move the decimal place 2 places to get 33.28 or 33.3 centimeters. A good starter problem. Okay, let's look at another problem. Very typical that you're going to be expected as an engineer to design a vessel. Okay, for this one, we're going to say, I want you to design a cylindrical vessel. Design a cylindrical vessel that can contain 3 cubic meters of a liquid. And the other part is the length of the vessel, or the height, has to be twice the diameter. Okay, we'll start with a sketch. And so here's our sketch. Cylindrical vessel, showing the diameter d, and I'm showing that the height or the length is 2d. And the volume has got to be 3 meters. How will we solve this? How will we solve for d? Well, we'll write down our government equation. The volume is pi over 4d squared. That's the area of a circle times L, the height. That's the volume of the vessel, pi over 4d squared L. Next step, so we're looking to find d. So I'll substitute 2D for L given in the problem. Let's see, collect terms. Okay, I see that a 4 in the denominator and a 2 in the numerator can be simplified, pi over 2, and collect the d's, d cubed. V is pi over 2, d cubed. Next step is what I want to do then is manipulate my equation to get d on one side or the other. In this case, the d cubed on the right-hand side is 2v over pi. Okay, good. Okay. Next thing I do is solve for d. Solve for d. D is going to be 2v over pi to the 1/3, or in other words, the cube root. And so the reason I wrote it like this, right, is because on your calculator, there's probably no cube root button, but certainly there is a to the power of 1/3. You can execute that. So we have an expression for d, okay? And then numerically, we're going to jam in, the volume was 3 cubic meters. So we'll jam that in to get d is 6 over pi to the 1/3 power, or the cube root, okay? And there we go. So the diameter is 1.24 meters. And so the length is twice that, or 2.48 meters. Not so bad, but that's the way you would show if this were a homework problem. Those are the steps you'd show, and you'd be using algebra to get to the result. I've come up with some examples and may be a little more involved. So this is an example from a thermodynamics homework problem. Solve for a single variable. Okay. The following mathematical model has been determined for a specific situation. And we're not going to go through the details of that, but it's let's look at these variables. Very typical in thermodynamics. Q sub n minus W sub out equals m times the variable C sub v times the quantity T2 minus T1. That's our mathematical model. Okay. And then in this mathematical model, the values are known for Q in, W out, M, CV, and T2. All those are known numbers, and the homework problem is determine T1. What's T1? Before we move on, can you think of how would you do that? Let's just take a little second to think about how would you solve for T1? Okay, let's move ahead. Here's the first thing I typically do when I'm solving these types of problems is on pencil and paper, I'll put a little check mark over top of stuff I know, all right? So I put checks over all those things I know. I put a question mark over what I'm trying to solve for. And that helps me see, to get a vision of the algebra I need to perform, okay? So let's go through the algebra then, all right? So let's see, I've checked off all the things I know, okay? Let's see, the first thing I would do would be, I'll put the left-hand side in parentheses and then divide both sides by MCV. So I've got a little better form there, okay? That's the first thing I did, okay? And then let's see, I need to solve for T1. And so what I'll do, I think then what I would do would be, I would take T1 and flip it to the left side, okay? This group of numbers I had on the left side, I'll flip those to the right side, okay? And that way I can solve for T1 equals. So T1 is simply equal to T2 minus the quantity Qn minus W out in the numerator divided by MCV in the denominator. So for this one, I didn't show every single painful step, and you wouldn't be expected to do that in your homework solution, but by golly, you would be expected to be able to get from here to here, and both of those I think would be logical to show on a homework solution. The fourth and final example, a little tougher example, taken from a thermodynamics problem. Solve for a single variable using basic algebra. Okay, here's another engineering model that we've got in a problem. Greek letter omega. Omega is known, equals the number 0.622 times P sub V. That's what we're trying to find, divided by the quantity P system, which is known, minus PV. That's what we're trying to find. So Omega is a number, 0.00504, and P system is a number, 14.7, and our job is to find PV. So let's look at, we've got our checks and our question marks. Oh, it's going to be a little tougher to solve for P sub V, isn't it? Because I've got P sub V appearing twice in one equation. However, I've still got one equation and one unknown. So I can solve, hopefully, for P sub V. Let's go through the algebra to determine it. All right. I think the first thing I would do as I'm working through my homework problem, I'd multiply both sides by the quantity P system minus PV. Okay, so there's my starter point. I've multiplied both sides by P system minus PV. All right. I'm not there yet. I don't have PV equals. So I think the next step I'll do is I'll multiply out, distribute algebraically the left-hand side. Okay. Yep, I did that, didn't I? P system times omega. Oops, where did that PV omega went? Oh, here it is. It's on the right-hand side. Here it is. I moved it to the right-hand side, and then I just kept the right-hand side written down. So I wrote that down. If I were doing this with pencil and paper as a student or as a practicing engineer, that's what I'd write down. Then I would try to collect terms on the right-hand side. I've got a PV here that I can collect, and in the parentheses, then I'll have 0.62 plus omega. All right, I'm almost there now. So now you're seeing, okay, I see where I'm going to go next. I'll simply, I flip the right-hand side and left-hand side, and then I'll divide both sides by the quantity 0.622 plus omega. So here we are, okay? PV equals P system omega, there's the right-hand side, divided by quantity 0.622 plus omega, got it, okay? And then I'm just going to jam numbers in for everything we know on the right-hand side, got it? Break out the calculator and get a numerical result. P sub V equals 0.11816. Okay. So how did you do? We went through 4 examples of using algebra in representative engineering problems. Now, all those examples, I would say, were fairly easy. You can get better and better at this. So think in your mind, and you get better at this by practice. And we can assure you that we're going to be giving you plenty of practice in mechanical engineering classes on this, particularly thermodynamics. How did you do? Let's think how you did. If you think, man, I sailed through this, I am ready. Well, that's great. That's good. Congratulations and welcome. Okay. We welcome all of you. Let's think, what if you said, man, the first 2, I got the first 2, but those last 2, I'm going to have to do a little refresher on that. Man, okay, you might choose to do a little refresher on your own for that. Maybe replay the video, something like that. Okay, all right. If you found that, man, those last 2 examples were Greek to me, man, I didn't understand how to do that at all. If that's the case, okay, if you really didn't understand how to quickly get to those results, I want to recommend that you go talk to your undergraduate advisor, okay? Set up a face-to-face meeting. That doesn't, so don't get discouraged, but I want you to work with your undergraduate advisor to get some assistance in getting up to speed. Let's say in those last 2 problems, how would you get up to speed in that? Now, help is available at Virginia Tech regarding this, but I do have to tell you that in mechanical engineering classes, we operate our classes at such a fast pace, sometimes a breakneck pace in class, that instructors, professors don't have the time to go through every algebraic detail step by step like we did in this video. So when you need help in those kind of mechanics, want you to work with your undergraduate advisor to set up some assistance in a different department. Okay, so mechanical engineering instructors and professors, we all want to help you. We want to help you perform and excel. Okay, if you really need assistance with algebra, your undergraduate advisor is going to be the key person in working with you to get that algebra help you need. Okay, I hope that helped. I hope that helped you evaluate where do you stand with respect to algebraic manipulations to get to a point where you can solve quickly for x equals blah, 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 and then break out that calculator and start numerically evaluating to get to a result. Okay, hope that helps, and encourage you to look at the next video in the series.